Well, hello there. My name's Miss Hughes, and I am here to get you caught up on the first lesson in Unit 0, Algebraic Tools, here in Grade 11 University Level Functions. If you were away this day, or if you're joining our class late, then you can use this little lesson to get yourself caught up. The first thing we looked at was adding and subtracting polynomials. So this is a bit of a review from grade 10. Polynomials, just as a reminder, are made up of a finite number of terms, so there's not an infinite number of them. They definitely have to end sometime. And you can tell that they're terms because they're separated by addition and subtraction. A monomial is made up of one term only. Binomial is made up of two terms, and a trinomial is made up of three terms. After that, we just use the prefix poly, meaning many. Generally speaking, when we add or subtract monomials, we create a polynomial, and each monomial within the polynomial becomes a term in and of itself. The terms themselves, so let's look at a few definitions here. The terms of a polynomial have variables, so x, y, z, that are raised to a whole number exponents, 0, 1, 2, 3, and so on. So the exponents can't be negative and can't be fractions. And these variables with their whole number exponents are accompanied by a constant or a coefficient that's forming a product with them. Even if you don't see a constant, then it's probably the number 1. But you'll find that constant or coefficient that's being multiplied by the variable, and that is your term. If it's just 1, then it's the monomial. Otherwise, it's a term part of your polynomial. If we look at an example, this one is a trinomial because we can see 3 terms. And we'll just sort of label the 3 terms that we see. If we go in descending order, exponent 2, exponent 1, and technically exponent 0, I'll get to that in a second, then the first term is called the leading term. And in this case, because it's x squared, we'd call it the quadratic term. The second term here we're going to call the linear term because of the exponent of 1 on the x. We don't see it, but we know it's there. And then this constant term, we don't see a variable, but in fact, if we were to multiply it by x to the 0, then we know that anything to the exponent 0 is 1, so 4 times 1 just gets us our 4 back. And that way we can see that the exponents do decrease 2, 1, and 0 technically in our trinomial. So just as a note, terms of higher degree are usually written first, and then we tend to go in descending order from left to right. Also, we tend to go alphabetically in order. If you have x's and y's, we tend to put the x terms first, and that's just convention. There's nothing wrong with it the other way. It just makes it easier to recognize what's going on in your polynomial if you put them in descending order. For example, you may remember from grade 10 that if you have a quadratic and you're graphing it, it creates the shape of a parabola. If you have these in the right order, then the leading coefficient, which is the coefficient on your leading term, if it's positive, your parabola opened up, and if it's negative, your parabola opened down. If we didn't have these in the right order, then at first glance, this would create a parabola that opened down if, say, we had the second term first. So just by convention, we tend to go in descending order. That being said, let's move on to terms. The ones that have the same variable factors, so same letters raised to the same exponents, are called like terms. And to simplify an expression containing like terms, we just find the sum of their coefficients. So if I've got 5x squareds and you've got 3x squareds, then together we've got 8x squareds. It doesn't change the item we're counting, the x squareds. It just means that in this case we have more of them. So instead of having 5 or 3, now we have 8 together. You may be subtracting them, so in which case combining the coefficients will yield a smaller value instead of a larger value. But we'll see. We'll do each example in turn. If we look at example A, then we've got the 2x squared plus 3x plus negative 4 minus x squared minus negative x plus 9. First thing I would recommend is that we distribute the signs into the brackets. So we'll do positive times a negative gets us our negative, and then negative times a negative gets us our positive. And that way we can open up the brackets, and now we're looking at a polynomial where we just have term plus term minus term minus term plus term plus term. And my recommendation, you don't have to do this, but my recommendation is that you take the squared terms and you combine them, you rewrite them together. You take the linear terms and you rewrite them together, and then you take the constant terms and rewrite them together. This step here is optional. You can go straight from here to here. At this point, we would just do 2 minus 1 to get the 1, and then 3 plus 1 to get the 4, and then negative 4 plus 9 to get the 5. And what we end up with is just a second degree polynomial. The second example, if you were in class, I just had everybody try on their own using this example just as a refresher, because a lot of people just forgot sort of what they were doing here. The negative times a negative, we simplify that to the positive, and then I did the same thing. We just collect our cubed terms and our squared term, there's just one of them, and then our 2 linear terms, and just the 1 constant. We combine them, gather our like terms, and we end up with a 3rd degree polynomial, noticing that we're following convention, going 3, 2, 1, and then x to the 0 if it were there. Which it is, we just don't see it. To add polynomial expressions, so if we were to take a trinomial plus another trinomial, like we're doing in the first example, to subtract one from the other, we just have to distribute the -1. So basically we multiply every term inside the brackets by -1 to open up the bracket, and then we collect the like terms. If we're simplifying this polynomial plus this polynomial, notice that in front of the brackets here, though we don't see it, is a plus sign. And if we distribute the positive into all of these terms, it won't change any of these signs. They'll still say positive, negative, negative. So we're going to imagine we've done that. We imagine we've distributed the positive in and opened up that bracket, and we end up with this trinomial freed from the brackets. The next thing we'll do is distribute this positive sign in to open up that bracket, and now we've got these 3 terms. And again, at this point, we can just gather up our squared terms, gather up our linear terms, gather up our constant terms, and we end up with another trinomial. Same thing here. Again, if you're in class, then you're just trying this on your own, but we'll run through it quickly. Imagine the positive is here. We distribute it in, open up the brackets. Those 3 don't change. The negative times a positive gets you a negative. Negative times a positive gets you another negative. And then negative times a negative gets you a positive. And now again, we have just a polynomial. Term plus term minus term minus term minus term plus term. So we can now gather up the like terms, and we end up with a 3rd degree polynomial. Notice convention, we're going in descending order. Sometimes you're asked to do more than one thing. So sometimes you may be asked to first simplify an expression and then evaluate it for certain values of the variables. So it's easier to simplify first rather than substituting the variables, because you find that there are fewer substitutions you have to make, so less likely to make errors if you'd first simplify the expression. So if we're taking this trinomial and then we're going to subtract this binomial and then subtract this binomial, if I'm subtracting these 2, then I'm subtracting each part. So again, first step, imagine there's a plus here, distribute it in, open up the brackets, get your trinomial, distribute the negative in, that becomes minus 7x minus 4y, and then distribute that negative in, becomes minus 4x plus 2y. Gather up my x terms, gather up my y terms, there's just one lonely little z term, and we end up with negative 2x minus 3z. This is much nicer than the expression that we started with, and that means now that if I want to substitute in x equals 4 and I want to substitute in z equals 0, that's going to be nice and tidy, and assuming I didn't make any errors here, then the likelihood of computational errors in here now will be way, way down. So if we sub in that x equals 2, yeah, I'm going to have to fix this. So apparently I subbed in x equals 2, but it does say substitute in x equals 4. So in class, we're going to have to fix this up for everybody. So we'll end up with negative 2 times 4 gets you negative 8, and then negative 8 minus nothing will still be negative 8. So that'll be corrected by the time you view this, and correct that in your notes for sure. There are lots of spots where you can make errors, not just simplifying or computing, but even just transcribing and translating the numbers down. So your homework for tonight is the worksheet that's attached. So again, we haven't given out the textbook yet. So these are the assigned questions that go along with this worksheet here. Bear in mind that if you've done these, but it didn't feel like you were proficient, you weren't fast and furious, and you couldn't attack these questions with confidence and get them all correct, then do as many others of these as you feel you would like to do. The goal, again, is to have a presence of attack where you don't have to worry or wonder what to do, and then when you're finished, you feel very confident and comfortable that you've done it correctly. So that sort of wraps up the first lesson in this unit. Watch out for errors. Your teacher will make them all the time, and we will catch you again next time.